So let's make the direct comparison between BBM92 and BB84, right? So if you wanted to implement BBM92, we know that for BBM92, you need a source of entangled photons. For instance, like a spontaneous parametric down conversion source, something like that, that generates a pair of photons or more, but a pair at a time, and sends them to Alice and Bob, who then decide what basis they're going to do their measurements in, and then they talk about over a classical channel about what basis they used, and then they can actually exchange a key by doing a process like that. But in that case, it really requires three parties, right? A source, an Alice and Bob. I guess in some cases you could have the source at Alice, and Alice could send them over, but she would also need to measure some of these. But if we go with this kind of three party method or topology, right? There are different ways that you can do this, right? You could have your source on the ground, at a ground station, and then Alice and Bob would be on drones, and then they talk to the source and they receive the photons from the source, and then they do their key exchange. In that case, the pointing and tracking technology needs to be, I think, needs to be even more involved. Because of the synchronization that it takes for Alice and Bob, right? And that they need to be able to say, okay, I received a photon that is correlated with the photon that you received, essentially, and the timing of arrival of those photons, essentially, for them to say that, it needs to be within a certain window of tolerance. But if the drones are swaying around and vibrating and not constantly getting closer and farther away from the source, the time of arrival will constantly be changing. For instance, and so the synchronization part of this protocol will be essential and very complicated to achieve something like that. But possible, I think, definitely possible. A different configuration could be, okay, what if we put the source in a drone and then we have two ground stations for Alice and Bob? Similar thing could happen where the drone is still vibrating and swaying around, so sometimes it's closer to Bob, sometimes it's closer to Alice. And even if you were to maintain alignment that way, it's difficult to keep the synchronization going at those levels. That would be the main difference, right? And the detection part of the system would be very similar to Bob's setup that we currently have here, right? He has, a single photon detectors. He's got some optics that he'll use to measure to sort the polarization or the incoming photons. So in theory, the setup would be similar to what Bob already has. And the only thing that would change would be how the source would change. That setup would be slightly different. Yeah.
Right. So different hardware constraints and different, size, weight measurement, power, etc.
For example, if you went with a SPDC source, you need a laser in that case, and you need some optics on that side to also, separate or to take the two photons and align them to Alice and Bob. So you need optics there and a laser. And I talked about some of the downsides of using a laser on a drone. It requires quite a bit of power sometimes, and it requires bulky temperature controllers. And specifically when we're flying, for example, for us that we were flying at night where temperatures can actually change quite a bit in a short amount of time, temperature controllers would be needed for that laser to actually laze at the wavelength that you want, which is required for SPDC sources. So.